Hello and welcome. So today we are going to be carrying out basic Ghidra tutorial. All right, and that is what I have here, basic Ghidra tutorial. So I'm going to show you how to use Ghidra to open and analyze a binary or an executable. Okay, so here I have an executable already, which I have compiled from this C source code here. So we have it as crack me. So I'm just going to open my, how do I call it? I'm just going to open Ghidra. So I have Ghidra downloaded to my downloads folder. What is that again? The folder Ghidra, Ghidra run. So I'm going to execute it right now. So we are just going to wait for it to run. Okay. All right. I'm just going to close this tip and let's create a new project. So I'm just going to click on new project, non-shared, next. I'm going to put it under our basic Ghidra tutorial folder. Okay. So select that and I'm going to call this, let's call this crack me project. Okay. Finish. Now let's import our binary, import file. So that should be crack me. That's the binary I compiled. Okay, so it's Ghidra automatically detected the language, the format, and also the destination folder and the program name. So just click on OK. All right, okay. Now click on this green dragon head here. Click on that. Okay, so just come over here, file, click on open. Now we have it here under our project. So select the executable there and click on OK. Yes. Analyze. Okay, so let me just make sure I give it a nice look. So tool options, listing display. I'm going to use Ubuntu for the font. Ubuntu Mono. Alright, yeah, Ubuntu Mono. And let's give it font size of, I think, 19. And also for the decompiler, I'm just going to do that for the display. I'm going to come over to, where should that be? Okay, font, Ubuntu, same Ubuntu Mono there. Okay, and I'm going to give it 19. I'm going to make it bold and then click on OK. Let me go back to the listing and check something. Okay, I want to make it bold also. So click on apply. And this is going to apply our changes. Okay, and then click on OK. Oops, sorry, that didn't work properly. So I'm just going to, come back there, edit. So let's go back there and listing display. I think this did not take effect. So I'm just going to do that again. 19, bold, apply. And let's wait for that to take effect. and then click on OK. All right, so we have it here now. Now let's go back to the compiler side and come over here to the decompiler, move over to display, scroll up, come over here, Ubuntu, okay. There is a font. Come, let me see. Sorry, or is that the analysis? Okay, nope. That should be the display background color. Okay. Comment line, minimally, font. Okay. Let's see what we have. All right, so this left pane here is the symbol tree. Okay, the symbol tree. Then the middle one here is the listing display. Okay, this displays the assembly code or the assembly representation of the binary. Okay, and then here we have the decompiler, which is going to decompile our program to be to look like the programming language that was used to build the binary. Okay, so if we made use of C to write, like if the program or the binary was built from the C programming language, you're going to see the decompiler output here looking like the C programming language, but not all that similar to the original source code. Okay, so we're just going to let me look for the function known as main. So come to functions here, scroll down a little bit. So we have the main function here, and this is it. So you can see the compiler output here. So I'm just going to shift this here. Okay, so this is the decompiler output. Now over here, if you notice, we have here undefined int main. But before that, let's try to execute the program and see what's going to give us. I'm just going to do crack me and enter key. So okay, this is going to ask us for a particular key which I don't know yet. Okay, I don't know, so let me just put in some values and see. Access denied. Okay, let me try something like John. Access denied. Try something like let's say QWERTY. Access denied. Let's try 3344. Access denied. So I don't know the key. Okay, so we are going to reverse engineer the program or analyze the binary to find out the key it expects from us. All right, so over here we have undefined int main, and remember, in the C programming language, the main function is the entering point of every program. Okay, you write in the C programming language. All right, so now since we have undefined main here, this is just signaling to us that Ghidra was not able to detect the return value of this main function. Okay, like it wasn't confident about it, so it just named it undefined 8. Okay, so what we are going to do now is we are going to move into the code. So we have here long in fs offset. All right, in fs offset. Now in Ghidra, the fs offsets or this variable here is used to hold the value of the stack canary where it is stored in memory. All right, so the stack canary is just like a secret value push onto the stack, which is just a form of protection against stack buffer overflow or stack smashing attacks or vulnerabilities. Okay, so it helps to protect against buffer overflow attacks on the stack. Okay, so that is what this this long in fs offset means. Okay, so this secret value is stored in a segment known as the fs segment. Okay, then we have here a local variable 18, local variable 14, local variable 10. Over here we have, now we can see here that the local variable 10 holds the value of the stack canary stored at this destination here. Okay, at this location, sorry, not destination, at this location, the fs segment plus 0x28. So it's stored here at this location. So the value of that the secret value or the stack canary is assigned to this variable local 10. So let's rename this to something stack canary value. Let's call it this. Okay, all right, so let's see the next thing here. So local 14 equals to 0x 4d2. Okay, and then we have here printf enter key. Now if you remember, when we ran the program, crack me, it expected a key from us which we don't know yet. Okay, so let's see, we don't know the key yet, so let's see, nothing yet. Okay, so let's see what it's going to do. So after it displays enter key, what it does is it expects input from the user, which is me. Okay, and this is the scanf function of the C program. And the scanf function, the first parameter it takes is the format specifier specific to the type of data we want to read into this memory location local 18. So let's see this. Let's click on this and see. All right, so this is it's expecting an integer or a decimal value from us. We have the format specifier here as modulo D. Okay, and let me open a notepad, so the text editor for this text editor here. So that's scanf. We are currently analyzing the scanf function. All right, so I'm just going to put this here. Let me increase the font. So scanf. So we have modulo D already now, and then we have ampersand, which is the memory which we want to read the user's input into, or which the binary wants to read the user input into. So this is local 18. Okay, so this local 18, let's rename it here to user input. Okay, user input, and click on OK. All right. Okay, so now we have line 14 here is an if statement comparing local 14 to user input. Okay, so from here this this is just trying to tell us that the user input is compared to the value of the user input is compared to the value of this local 14 variable. So from here you can have a correct guess that once we run this and it's expecting a key from us, let's put this 4455. It compares this user input to the key which it is expecting, which is stored inside local 14. So let's right click on this and rename variable, and let's call this secret key, which the binary is expecting. Okay, so once the user supplies the input, we have if secret key is equals to the user input, access granted, but we've been getting what? Access denied. All right, because we have not been able to guess the right key. So what do we do now? Okay, let's see what we're going to do now. So what is the we're going to look for the value of the secret key. All right, so this is, you can see the value here is 0x4d2, which is displayed in this listing display view here. We have it as 0x4d2. So what is 0x4d2? In decimal, we have it as 1234. Okay, 1234. Now let's check that out. So let's try to put in 1234. Voila, access granted. So we've solved the program. All right, we've we've been able to identify the secret key, which is binary, or this program accept, which is what? 1234. Okay, all right, so after that it displays access granted, and then we have a check here from line 20 to line 23. Now remember I told you the stack canary is a secret value pushed onto the stack, which helps to protect against buffer overflow attacks. Okay, so whenever there's a buffer overflow and the user input overrides the secret value pushed onto the stack, what happens is that the this check here is going to return, sorry, is going to execute the stack check failed, because the buffer overflow vulnerability or attack has overwritten the secret value or the stack canary push onto the stack. Okay, so this is going to return stack check fail. So you can see stack canary helps to protect against buffer overflow. Okay, it's one of the protection against buffer overflow attacks or stack smashing attacks. All right, so it compares the value which is stored before the program ran, okay, and with the original secret key or the stack canary value pushed onto the stack. Okay, so it compares them to see if the program is still okay or healthy. Now, if the user input was very large and is going to overflow or override the stack canary value pushed onto the stack, and which means this particular check here will fail, and we'll have what? A stack check fail. Like the stack check fail function is going to execute to this alert us that there was a buffer overflow attack or something like that, or the stack canary value was overwritten. All right, So that is how to do that. Okay, now what about if you don't know the secret key this program is expecting? You can patch the program. Okay, let's try to patch the program. So I'm just going to click on this to find where it's located. So I have it here. So I'm going to right click and click on patch instruction. So once I click on patch instruction, it's going to construct the assembly. Okay, we have it here constructing assembly. So we're going to just wait for it for some minutes or some few seconds, and for it to finish constructing the assembly. So this it has finished constructing the assembly. All right. So since we let's say before running the program, you don't actually know the secret key this program is expecting. So what you can do is you are going to try to look for a value that you something that you know, okay, that you can insert there. So let's say I tried this at first and I didn't know that the secret key it is expecting is 1234, and I keep on trying and I keep on getting access denied. So I can decide to say, okay, I want the program to make use of the secret key I have in mind. So something like maybe 4444. All right. So we're going to look for the hex value of 444. So let me see if I can open my calculator and let's look for the hex value of 444. Okay. So that we can insert it there. Let me see. Basic, no programming. All right, so let's see 444. So 444 in hex is 1BC. Okay, yeah, 1BC. Let me see if that is correct. So I'm just going to try 1BC. All right, so it is 1BC. Okay, 444. So I'm just going to come over here and change this to, I'm sorry, let me do that again. Patch instruction. Okay, one, I think I have it as 1BC. Okay, so I'm just going to hit the enter key. All right, you can see it here. We now have it here as what, 1BC. So once I'm done, I'm just going to come to file here, export program. Then I'm going to give it, let's just give it the format original file. Okay, and I'm going to select the output file. Let's call this output mod. That is the modified. Let's give it the name crack me mod. Okay, modified. So I'm going to click on OK. All right, click on OK. Now I'm going to come to my terminal here. It's in my home directory. So cd back to ls grep crack me mod. Let's see. Okay, we have it there. So let me run it and see. Crack me mod. Okay, permission denied. I'm just going to give it execute permission. Crack me mod. Hit enter. Put in my password. Okay, clear the screen and then run it again. Crack me mod. Now let's do the 4444. You can, oh, access denied. I wasn't expecting that. Let's see. Was that an error? Okay, 444. Sorry, 34 only. 34. Right. So I'm just going to run 1, 2, 3. Boom. We have what? Access granted instead of the original 1, 2, 3, 4. The author of the program or binary expected the program to accept. So we've now manipulated it or patched it to accept 444. All right. So that's how to patch instructions on your Ghidra. Okay, using Ghidra to patch instruction or bytes of a program or binary. All right. So thank you for watching, and if you know you've not subscribed to my channel, please do wait to hit the subscribe button and don't forget to turn on the notification bell so that you don't get to miss any of my video. Okay, so thank you for watching and see you next time. Bye.